Hi everyone, this is Dr. E. Devi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to study the basis of Gauss Law and its applications. On completion of this video, the listeners or learners can able to understand what is Gauss Law and the basis of Gauss Law and where it is used. So first we will discuss about the statement of Gauss law. The Gauss law states that the total electric flux through a closed surface is equal to the charge enclosed divided by the permittivity of free space. So charge enclosed is given as Q is the charge enclosed is Q enclosed. So mathematically it is given as phi E. Flux phi is nothing but the electric flux. Phi E is equal to surface S for surface integral, otherwise it is known as double integral. E dot dA is equal to Q enclosed divided by epsilon naught. So Q enclosed divided by permittivity of free space. Epsilon naught is called as permittivity of free space. Phi is nothing but electric flux, E is the electric field, and dA is the electric differential area vector quantity. Q enclosed is the total charge inside the surface, and epsilon naught is the permittivity of free space. And Gauss law applies to closed surface only. That is why we mentioned that formula as closed surface, that is integral middle of that circle represents closed integral. It is most useful in the systems with high symmetry. So application of Gauss law, it is mainly used in electric field due to point charge. For a charge q, the choose the spherical Gaussian surface of radius r. So spherical Gaussian, so sphere means spherical, so its surface area is noted as 4 pi r square. So E into 4 pi r square is equal to Q divided by epsilon naught. So E is equal to 1 by 4 pi epsilon naught into Q divided by r square is nothing but the electric field due to a point charge. This is same as the Coulomb's law. Then electric field due to infinite line charge. So for infinite line charge, for a long wire with line charge density lambda, take a cylindrical Gaussian surface. The flux is denoted as E into 2 pi RL. 2 pi RL is nothing but the surface area of the cylindrical shape. E is equal to lambda L divided by epsilon naught. So E is equal to lambda divided by 2 pi epsilon naught into R. Then electric field due to infinite plane sheet of charge. So surface charge density sigma, use the pillbox as a Gaussian surface. So phi is equal to 2 into EA. So 2 EA is equal to sigma A divided by epsilon naught. From this E is noted as E is equal to sigma divided by 2 epsilon naught. So electric field due to a spherical shell, that is conductor. Outside the cell, that is small r greater than capital R. Small r is in radius, and E is equal to 1 by 4 pi epsilon naught into Q divided by R square. It acts like a point charge at the center. Inside the shell, R is less than capital R, so E is equal to 0. So all charges reside on the surface is nothing but the perfect shielding. So electric field inside this solid non-conducting sphere. Let us consider the charge density, uniform charge density rho. For point inside R is less than R, enclosed charge Q enclosed is equal to rho into 4 by 3 pi r cube. Applying Gauss law, it will be E into 4 pi r square is equal to rho 4 by 3 pi r cube divided by epsilon naught, that is equal to E is equal to rho r divided by 3 epsilon naught. Let us have one problem based upon this, that is flux through a cube, point charge at center. Having the problem that is a point charge Q is equal to 12 microcoulombs is placed at the center of a cube. What is the electric flux through one face of the cube? So electric flux is asked. We have to calculate this phi. Phi is nothing but electric flux. According to Gauss law, the total flux through closed surface, that is according to this law, is noted as phi total is equal to Q divided by epsilon naught. So the flux is distributed equally among 6 faces, that is symmetric faces. So flux per use is same in all the 6 faces. So flux per phase, that is 5 phases, is equal to Q divided by 6 epsilon naught. 6 is because of 6 phases are there. Converting this, Q is equal to 12 into 10 power minus 6 coulombs. Substituting this one in this formula, substituting this epsilon naught value, that is epsilon naught in free space, permittivity in free space, and Q the values substituting, and finding Q value, it will be 12 into 10 power minus 6 coulombs. Now 5 phase is equal to Q divided by 6 epsilon naught. Substituting the above Q value and epsilon naught value, 5 phase is equal to 8.854 into 10 power 6, that is 0.22 into 10 power 6. Computing and rearranging this one, 5 phase is equal to 2.26 into 10 power 5 Newton meter square by coulomb. So this is nothing but the flux which is around this phase. So in this Q means totally 6 phases are there. So each phase will have this flux value 2.26 into 10 power 5 Newton meter square per coulombs. So this is what the application of Gauss law. Hope you all understand this session. Thank you.